All right, today we are diving deep into some of an architect's most powerful tools, the advanced routing policies inside AWS Route 53. We're going to cover how you build for disaster recovery, how you manage global traffic with surgical precision, and of course, how you make sure everything stays highly available. Let's get right into it.
Let's just start with a really high-stakes question. Imagine an entire AWS region goes dark. Your main servers, totally offline. What are your users seeing? A total outage? What is your plan for that kind of digital disaster? It's a scenario that every single architect has to be ready for.
Well, the answer, your first line of defense, it often lies in a place you might not expect it, your DNS. Seriously, by using intelligent routing policies, you can build systems that are incredibly resilient, compliant, and always on. And it all starts at the DNS layer with Route 53.
So let's kick things off with the most critical policy for disaster recovery, failover. This is your absolute go-to when your primary systems are on the line and things go wrong.
At its heart, failover routing is all about an active-passive setup. You've got your main or active resource doing all the work, and then you have a backup or passive one just sitting there, waiting in the wings. The whole point is to automatically, instantly switch to that backup the second your primary resource gets sick.
And this flow, it's just so simple and so powerful. First, Route 53 is constantly running a health check against your primary endpoint. It's basically pinging it every few seconds, asking, hey, you still good? As long as the primary says yep, all your traffic goes there. But the instant it fails that check, Route 53 becomes this traffic cop, immediately waving all of your users over to your secondary record. That right there is DNS-level disaster recovery in action.
Now, this is absolutely crucial to understand. And by the way, it's a classic interview question. What's the difference between DNS failover and a multi-AZ architecture? Well, multi-AZ is all about high availability within a single region. It's handled by a service like an application load balancer. Route 53 failover, on the other hand, is for disaster recovery across entire regions, and it's all handled at the DNS level. They solve totally different problems at totally different layers of your architecture.
Okay, so we've covered surviving disasters. Let's shift gears now and talk about serving a global audience. I mean, when your users are scattered all over the planet, you need much smarter tools to get their traffic to the right place.
So, our first tool in the toolbox for this is geolocation routing. And it's pretty much what it sounds like. It looks at where your user's DNS query is coming from, specifically what country, and it sends them to the endpoint you've already set up for that exact country. Simple as that. Now, here's the twist. You might think this is all about performance, right? Sending users to the closest server? Not really. The main reasons you'd use geolocation routing are almost always business and legal requirements. For instance, you might have to make sure all your European user data stays in EU data centers to comply with GDPR. Or maybe you have content licenses that say you can only show a movie in certain countries. Geolocation is the policy that enforces those rules right at the front door.
Okay, next up is geo-proximity routing. It sounds a lot like geolocation, but it's a completely different beast. Instead of routing by country, geo-proximity routes traffic based on the actual physical distance between your users and your AWS resources.
And this is where the magic happens. The real power of geoproximity isn't just sending users to the closest server. It's that you can apply a bias. Think of it like a dial you can turn to either expand or shrink the geographic area a resource serves. This lets you do really advanced traffic management, like slowly shifting traffic away from a region that's getting overloaded, or maybe sending more users to a cheaper region, all without taking anything offline. It's incredibly powerful. All right, let's switch gears to something a bit simpler. A policy for basic high availability that doesn't need all the complexity of a full-blown load balancer. This is multi-value answer routing. You can think of it as a much smarter, modern version of old-school DNS round robin. When a DNS query comes in, Route 53 doesn't just give back one IP address. Nope, it returns a whole list of up to 8 healthy IP addresses, and then the client, the user's web browser, just picks one to connect to. But the real game changer here is that one little word, healthy. Unlike simple round robin, multi-value answer routing is tied into Route 53 health checks. So it will only return the IPs of endpoints that are actually online and working correctly. This makes it a fantastic, low-cost option for basic high availability, especially if you need to route to servers that aren't even on AWS. Okay, we have thrown a lot at you, so let's pull it all together. Let's boil it down into a super simple playbook you can use for your next architecture design or, to absolutely nail your next technical interview.
This table is basically your cheat sheet, so think of it like this. For active-passive disaster recovery driven by health checks, you use failover. For compliance-driven, country-based routing, you use geolocation. For that advanced traffic control using distance and bias, that's geoproximity. And for simple, high availability with multiple healthy answers, you reach for multi-value. Got it?
Look, knowing the tools is great, but knowing the traps is even better. And trust me, these are the classic mistakes people make all the time. Remember, DNS failover is not instant. It's always going to be limited by DNS caching and your TTL settings. Geolocation is for compliance, not for finding the fastest connection for your users. And please, multi-value routing is not a replacement for a proper load balancer. It knows nothing about server load or keeping the user session on the same machine.
So if you're heading into a design review or an interview, I want you to burn these 4 lines into your brain. First one, failover routing enables DNS-level disaster recovery. That perfectly sums up its purpose.
Second, geolocation is compliance-driven, not performance-driven. This one clears up the single biggest misunderstanding about that policy.
Third, geoproximity allows for bias-based traffic shifting. This highlights its totally unique superpower for advanced traffic management. And finally, maybe the most important one, multi-value routing is not a load balancer. Just knowing this can save you from making a huge architectural mistake down the line.
So, we've seen just how powerful DNS can be, especially when it knows a resource is unhealthy. But that really leads to one last crucial question. How does DNS actually know? Sure, your DNS can see when a server is down, but can your application, your actual software, tell your DNS that there's a problem inside the app? That connection is absolutely key, and well, it's a topic for our next explainer. Thanks for tuning in.